It sounds weird to say a standard. Like, what does that mean? A standard, does that mean like it's an RFC? Does that mean that it's published on the internet? And like, yes, that's true. It is a standard. It is published on the internet. But what we really mean when we say a standard is we're talking about something that's repeatable and consistent. It's a way of doing something that you're going to see throughout these slides that's repeatable and that you'll notice like the trends that are happening and that are common throughout. So it's a common transport. It's a common approach. And we're going to apply this approach to each instrumented protocol. So I first met Peter when I was giving a talk last year on graphite, and I needed metrics for my talk. And giving a talk on graphite without actually showing any graphs or anything interesting would be really boring. So I was looking at who was going to be speaking that night, and I saw Peter was presenting on sFlow, so I figured I should check this out. I actually worked with sFlow in the past on like my Foundry switches, so I was a little bit familiar with it. So just to get an idea, like who here has networking gear that's not made by a vendor named Cisco? All right, excellent. And has anyone here used sFlow on their switches or even on their hosts? Great. So not a whole lot of people, so you guys are a perfect target audience for learning about this kind of stuff. So I sat down, I started playing with host sFlow. I'd seen it on the Ganglia mailing list. I knew it was something that was just being integrated into Ganglia, but I didn't really know exactly why or how. I knew what I knew about sFlow from networking. So I started playing with the host sFlow, and basically like 20 minutes later and a little bit of Perl, I had all my sFlow metrics going into graphite, which was awesome. I just could not believe how easy and how fast that was. So after the talk, Peter was really shocked that I'd actually presented sFlow stuff for him after he had already spoken. And we started talking, and Tagged is pretty fanatical about monitoring, and Peter wanted to be able to validate his approach, so it seemed like a good match. And Peter's also really fanatical about sFlow, so much so that last year I asked him about this thing that we were starting to work with at Tagged called Node.js, and if he had thought about supporting it, and the next day he had a working implementation of sFlow with Node.js. So that was pretty awesome. And you can see there's a lot of 404s here on the right graph, and if you want to know what those are all about, you can find me in the hall or at our office hours later. So Tagged is a social networking company. We do about 5 billion page views a month. We run about 4 terabytes of main Memcache, and we're heavy users of Apache, PHP, and Java. We use Ganglia so much that if you walk around the office pretty much any time of the day and you look at someone's screen, you're almost definitely going to see Ganglia on the screen. We use it whenever we're going to deploy something, whenever we're going to change something. Everyone's glued to their monitors watching Ganglia. They're also watching an internal tool, but we really like it, and it seemed like a really good fit for us. And we also use Puppet for configuration management. So when we started investigating host sFlow, making the change from Ganglia's regular gmond processes over to host sFlow was super easy because we had a lot of this infrastructure already in place. The things that we really like about open source host sFlow is it gives us automatic visibility into our applications. I like to call it drop-in visibility because it's actually that easy. And it's also made our network a lot more efficient. And when you're working on a big social networking like this, site like this, it's not so much the bandwidth that you're pushing around, it's actually your packets per second. And anything that we can do to make the network more efficient is a really big deal. So I'm going to hand it over to Peter. He's going to give you guys a little more background about the actual nuts and bolts of sFlow.
So this is a diagram you probably all recognize. It's a scale-out, multi-tier cloud architecture like Tagged's. An interesting thing with scale-out architectures is you have these dynamic server pools. They give you high availability and allow you to adjust capacity to changing demand. But it makes them challenging to monitor because they are very dynamic environments. What's unusual on this slide is the inclusion of the network. People often conveniently ignore the network because it's hidden behind APIs. Unfortunately, that's a big mistake to make because any kind of distributed application is tightly coupled, its performance, to that of the network. The other thing you'll notice is that the network crosses all your tiers. And so if you have performance problems in the network, they do allow problems to propagate from tier to tier. And that's what this animation shows, is a general kind of meltdown being propagated through the network. And one of the reasons for this is a lack of visibility into the network. For example, applications typically use request timeouts as a way to trigger failover behavior. And what's unfortunate about that is a timeout collapses multiple states. You can't really tell whether the service you're trying to access is down, busy, or perhaps the network is congested. And if the network is congested and you fail over, you risk tipping yourself over the edge as you replicate and move data. So what network visibility provides you is a way to detect dependencies and also to detect any resources that are congested that could cause you failures. So switch vendors implement instrumentation in their hardware. And the sFlow standard was developed by a consortium of switch vendors in order to ensure interoperability. Today, most vendors implement the sFlow standard, and network visibility is a question of product selection. More recently, the sFlow standard was extended to include server and application performance metrics. The host sFlow agent is an open source project that exports server performance metrics, and it forms the core of an ecosystem of related projects that embed sFlow instrumentation in an increasing range of applications, many of which you probably recognize on this slide. So let's take a look at the kind of measurements you can get with sFlow. And don't worry, I don't expect anybody to read this slide. The point of the slide is that counters are a staple of network and system performance management, and that extensive numbers of counters are maintained by switch hardware, operating systems, and applications, but that those counters don't really do you any good if they're stranded in all those devices. And so what sFlow provides is a really efficient way of getting those counters out of the devices so that that data becomes actionable. So what is sFlow? Well, it's a really simple protocol. Each of those blocks of counters that I showed you in the previous slide is encoded using the XDR standard and exported as UDP datagrams. And each datagram can contain hundreds of metrics. It requires minimal configuration, just the IP address of a collector and a polling interval. And it solves a problem that you have in sort of cloud systems where servers are added and removed, started and stopped all the time. If you're trying to maintain a set of servers to poll for metrics, that doesn't really work because the pool of servers is changing so quickly. With sFlow, as soon as a server starts up, it sends metrics, it's immediately detected and continuously monitored. In this example, we're kind of looking at this sort of scalability. So suppose you wanted to collect 50 metrics from each of 100,000 servers at 30-second intervals. With sFlow, that generates around 3,000 UDP datagrams per second. sFlow datagrams are really easy to decode. XDR is a very simple encoding. And storing that data so it can be usefully retrieved is a little more effort, but easily accomplished on a single server. So now that you've got sort of a basic idea of the sFlow protocol, let's look at some of the things you can do with the data. So metrics are very useful for characterizing performance. I'm sure I don't need to tell any of you that. And operations dashboards are covered with trend charts displaying everybody's favorite metrics. And the power of a trend chart is that it summarizes vast amounts of information. If you look at this example here, it's from a network link that's carrying over 14 million packets per second. And I'm plotting things like the number of packets that are broadcasts and multicasts, the number of error packets. And nearly 1 billion packets are summarized in every data point on that chart. So now that you have this chart and you see these big spikes, where do you go next? And that's where the second part of sFlow comes in. Random sampling is an integral part of the protocol. And for roughly the overhead of maintaining one additional counter, you get detailed visibility into transaction attributes, response times, status codes, and data volumes. So continuing the example, this slide is the same data as the previous page, but broken out now using the samples. And so we can see that the increase in traffic is due to 3 roughly equal connections. We can see details about those connections, the client, the server, the protocol, the data volumes. And it's this kind of detailed visibility that you need in order to truly understand what's driving demand on your resources and plan possible corrective actions if it's causing you problems. Sampling doesn't just apply to network packets. It applies equally to HTTP requests and Memcache operations. And Dave's going to be providing some additional examples later in the talk. So stepping back, sFlow provides a way to pervasively instrument your data center infrastructure. And embedding instrumentation within the infrastructure dramatically reduces operational complexity, since the instrumentation is deployed along with the resources that you're using to deliver services. And it ensures that all services are monitored. The other thing it gives you is an integrated view of performance, the performance of each application instance and the network and server resources it depends on. So for example, if you have a problem with performance on your Memcached tier, it could be something like a misconfigured client, it could be swapping on some of your servers, it could be packet loss in the network. And with sFlow, you can get centralized visibility into all of those resources in an integrated manner. Another important thing is that standardizing metrics breaks the dependency between applications, performance analysis applications, and agents. Typically what you do now is you deploy application-specific agents on each server. And the more applications you're interested in using, the more agents you have to deploy on each server. And I've seen people with 2, 3, 4 different agents all exporting similar metrics. By standardizing the metrics, you have a single embedded agent exporting a standard set of metrics, and you get consistent reporting no matter what performance analysis tools you choose to deploy. On the agent side, standardizing the metrics allows you to efficiently embed them within the applications and get consistent results. So for example, if you're monitoring your web tier, it doesn't really matter whether you're using Apache, Nginx, or Tomcat, you'll get the same kinds of metrics using sFlow. And so I'll hand over to Dave to describe Tag's experiences with sFlow and provide some examples. And he has some really interesting case studies that he can show you.
Thanks, Peter. All right, so as you may have guessed, since we've been talking about it this whole time, Tag uses sFlow. So how do we use it? We use it in a variety of different ways. So on our Apache servers, we're using mod sFlow. You drop it in, you restart Apache, it works. With Java, we use an sFlow agent, which is basically a jar file you drop in. You give an agent argument on the command line, and all of a sudden you have your instrumentation. And Memcache, we're using via some source patches that are available for Memcache, and that does the instrumentation. And then we're also using host sFlow. So host sFlow is our current replacement for gmond. And it's important to note that I'm going to give a lot of examples that have a lot to do with Ganglia, mostly because we use Ganglia, but there's actually nothing stopping you from using any of these metrics with any of your monitoring tools that you're used to using. So we also use Cisco switches and routers. So we don't actually get all the sFlow stuff that we would get if we had other routers or switches down to the sFlow level. But we use NetFlow wherever we can. It sort of fills in some of the gaps. It's a little bit not as much information as you can get from sFlow. And we still do some SNMP polling. So I kind of think polling sucks, but that's the way it is. Like sometimes you got to get it. sFlow doesn't cover every single aspect of everything that you would ever want to monitor. If you're doing polling now, it's likely if you pick up using sFlow, you're going to have to do polling later too. That's okay. So what does this all look like? Hopefully you guys can all read all the things on here. So this is an example of a standard way of setting up sFlow with Ganglia. This is kind of what we're doing. If you have any questions about this diagram, or you have a diagram of your own you want someone to look at, find us after. We'll be at office hours today. Be happy to go over it with you. So sFlow is integrated with all the latest versions of Ganglia. So any rules that you know about scaling Ganglia apply to scaling sFlow with Ganglia. So let's kind of walk through this. So on the bottom, we have a cluster, and this could be any cluster. This could be your Node.js cluster, it could be your Solar cluster, it could be web cluster, it doesn't actually matter. And here, for a cluster, we're actually talking about it like in Ganglia's sense of a cluster, which is like a grouping of machines that you want to see all together. And so this cluster is exporting data. It's sending gmetric data and sFlow data to gmond-do1 and gmond-do2. And the cool thing about all this, especially the way that we've set it up, is that we have a gmond.conf and we have an hsflowd.conf, and those are all generated out of Puppet ERBs. So there's actually no work when we're deploying a tier, we're growing a tier, it doesn't matter, all this data winds up in the same place. So I said before, well, we don't use gmond anymore, so that's kind of weird, right? Why do I have a gmond.conf on a host that we don't use gmond for anymore? Well, the reason is that if you use gmetric, for those of you who are familiar with it, it looks at your gmond.conf to figure out where to send the metrics to. So if we keep deploying a gmond.conf on here, we don't actually need the gmond daemon running, but at least all the things that we have set up already to send our gmetric data, that all just keeps working. And everything that was coming through the gmond process before for system data, that all keeps working too, because that's all coming through sFlow. So those go out to our redundant gmond servers. We have multiple gmonds running on each of those, one for each cluster. And again, all that stuff is generated out of Puppet ERBs. And then for those of you familiar with Ganglia, we have our main Ganglia server, which is running gmetad, and that does polling of the gmond servers, whoever's up, and collects the metrics and writes them out to ERBs or to RRDs, and that configuration is also generated out of Puppet ERBs. And then we have sFlow data going to an sFlow collector. And an sFlow collector is basically anything that understands sFlow. So you could actually call the gmonds an sFlow collector because they actually understand sFlow. But like on this one, we have a parser daemon that's analyzing the sFlow data as it's coming in, and we can do stuff with it. And then on the bottom right there, around 4 or 5 o'clock, we have sFlow data going out into outer space. Well, why do we have data going into outer space? Well, this is kind of give you an idea that you can send data to as many different locations as you want with sFlow. You can define in your hsflowd.conf a bunch of different places to send it, and the data will go to those places. It's just a UDP datagram. You're not like flooding your network with all kinds of crazy stuff. It's like that joke about UDP, like, I tell you a UDP joke, but I can't guarantee that you'll get it. So you can take your data, you can send it wherever you want. If you want to send it into like a message bus, like Kafka, you can do all that. It's your data, you can do whatever you feel like. So let's get into looking at some fun graphs. So our first example is going to be HTTP, and this is really going to lay out like the idea of what we're going to be doing here. So with HTTP, like Peter mentioned, it can be anything that speaks HTTP. It can be Nginx, it could be Node.js, it could be Tomcat, it could be Apache. It doesn't matter. It's all the same metrics. If you want to switch from Apache to Nginx one day, you can do that. Your graphs are not going to change unless you get some crazy efficiencies or something like that. But you're going to get things like your response codes, your 200s, your 300s. You're going to get your methods. But you're also going to get things in addition to counters. You're going to get your URL durations. You're going to get frequency of how often these URLs are called. You're going to get response sizes for the different URLs that are going to be called. And the nice thing about sFlow is all this data just comes flying at you. You don't have to do anything. So there's no more like setting up a big farm full of servers with a bunch of Perl regexes that are going to go through all your Apache logs and pull out all your response codes and then try to shove that into a data. You don't have to do any of that. Like sFlow is just going to send all that data to you right away the moment it happens in real time. It's pretty incredible. And when we first deployed sFlow and we saw all this stuff show up out of our Apache servers, everybody was like, whoa. So this is to give you an idea that you can view your entire stack at once. So we have CPU graph on here, we have a network graph on here, and we also have like Apache response codes and Apache methods. And you can slice and dice whatever you want. This is Ganglia. If you did this with Graphite, you could do the same thing. You could pull whatever metrics that you have and combine them together. So here we can see like there's some I/O weight. This is actually our static tier, so it's serving all static images. And this is basically the servers waiting on the back-end storage to serve them the images so they can send it out to the CDN. I don't really care too much that it has some I/O weight on the storage back-end because the first person that requests it's going to get slow, and then for the next month, everyone's going to get fast stuff off the CDN. We can see network traffic. We can see HTTP metrics. And then, you can see on like the response codes here, there's like some 404s. Like, I'm not sure what that is. Like, maybe that's like banned content that we stripped out of the site so we don't serve it out or anything like that. But this is a static assets tier. So everything that you're seeing it's all GET requests. Like that kind of makes sense. There's no posts. But we're not just looking at, GETs. Like we all have dynamic web environments. There's all kinds of things going on here. So here, like, we're seeing gets and posts, and this is all a roll-up. This is across an entire tier, like hundreds of servers. And it's so easy to make graphs like this. If you're using like one of the later versions of Ganglia, like gweb 2.0, where Vladimir and all those guys have been doing incredible amounts of work and making everything really simple, this is just a few lines of JSON. You drop it in, you hit refresh, and all of a sudden you've got this incredible roll-up view of hundreds of servers. You can actually get a real idea of what's going on. And this is the reason that people at Tagged have Ganglia up on their screen when they're doing deployments, because they want to see what's going on. And so for us, like, our update interval from sFlow is about 15 seconds. So it's just enough time for you to like look at the graph, understand what's going on, hit refresh, and all of a sudden you've got new data again. So that would be pretty cool if we just were able to look at counters. But we can actually look at other things with sFlow as well, and this stuff is all being streamed at us. So here we're looking at the top 15 URIs on the website by performance, and this is a mishmash of a whole mess of web servers. So on the top we can see like there's this thing that says upload, like this upload iframe. So what's going on there, like upload iframe? Well, you know, people go out at night, they take pictures of themselves and their friends. They come back the next day, they want to put all their pictures up at Tag because it's a social networking site, and you know, some people are on 15K modems. It just takes a long time. That's why it takes 8 seconds to upload something occasionally. But we look down further, and, you know, we're operators, we want to know what's going on the site, and we see there's a bunch of things that say pets. Well, pets is the most popular game at Tagged. If pets is going slow, that's not so good. So, you know, not that everything on the pets pages is going slow, but there's a number of different places that we see this. So, you know, what can we do about it? I'm an operator. I want the company to do well. Well, I can go over to the developers and I can be like, hey, you know what? I'm looking at the slowest URIs on our site and I see pets on there. Like, that's not cool. Like, what can we do about it? So maybe we can work with the developer. Maybe we can get faster page times for the pets game. Faster pages means more revenue. More revenue means happier, pointy-haired people walking around the office. That's good for me. So this is like true DevOps collaboration. This is a tool that will enable that kind of thing. And you can slice the URLs however you want. So it doesn't have to just be duration. It can be operations per second. It can be bytes per second. All those things are fine. On this actual tool, you can see like there's a prevalence for each of the URIs in the graph. You can click on it. This is all updated every minute. It gives you a whole lot of visibility into what's going on your website kind of all the time in real time. So that's pretty cool. We've seen a bunch of stuff about Apache, but what other kind of things can we instrument? So with Memcache, there's lots of counters that we can look at. We can look at hits and misses. We can look at operations like gets and sets. We can look at bytes. But just like when we were looking at HTTP and we could look at URIs, in Memcache we can actually look at keys. And this is kind of crazy to get this kind of visibility. So previously, if you wanted to look at Memcache, like how did you do it? You telnetted to the Memcache port, 11211, then you type stats, and then it would spit out a whole bunch of stats, and then you got to process that and send it off to something. And that worked okay, but there's even like scary stats commands, right? Like if you type stat sizes, it can basically lock your entire cache while it's running through memory trying to figure out the size of everything. And there was other ways to do this in the past, like you could do kernel patches where there's something called Gear 6 Advanced Reporter, and that could kind of let you look at it. But to get this like non-invasive granular instrumentation, you couldn't do that before sFlow. And now with like a couple of patches to the Memcache source, you recompile, you get all this stuff streamed to you in real time. So here's an example. This is a cold cache ramp up. And the reason I have so much stuff about cold caches is because when Tag was converting over to sFlow, I had to go through all of our servers and rebuild them. So we had a lot of cold caches while we were rebuilding servers. But there's a lot of really fun stuff that came out of here. So this really gives us a top to bottom view of the instances. I could have anything I want on here. I could have CPU, I could have file descriptors. But like I have some things, it shows how many items are in the cache. It shows the throughput. It shows like get hits and get misses. And that bottom right graph is actually get hits and get misses. And one of the cool things that you can see on here is that the hits rapidly overwhelm the misses. And this is something that we would expect, right? If we have our Memcache server, it's cold, we turn it on, everything should be a miss in the beginning, and then you'll find that, you know, your traffic is pretty repeatable. You're coming back for the same stuff if you're running your Memcache stuff well. And then, pretty soon the hits overwhelm the misses. And one of the great things is, this can get kind of dramatic, is Memcache is actually protecting your DB. So here you can see a tag. We run 6 instances of Memcache on each of our Memcache servers. I can get into why that is at another time. And this is really the throughput on startup. And one of the cool things here is if you look at the magnitude of the numbers, you'll see that the reads are being measured in single digits in megabytes, and the number of writes is being measured in hundreds of K. Well, that kind of makes sense, right? We're going to have more reads than we're going to have writes. But if you wait a couple of seconds later, you can see the number of reads has massively overwhelmed the number of writes. So much so that RD tool has said, wait a second, I've actually got to rescale this entire graph to be able to show this to you. And the graph on the left is actually just the left side of the graph on the right. This is exactly the same time period a couple seconds later. But you'll notice that the number of reads is now measured in hundreds of megabytes, while the number of writes is still measured in hundreds of K. Well, this differential here, that big red thing that you see on the right, that's what Memcache is adding to your architecture and saving your database. If you didn't have Memcache, you could do all the stuff that's on the left. With Memcache, you could actually do all the stuff that's on the right. It's incredibly powerful to be able to see this stuff happen right in front of your eyes. So, but similarly, just like we talked about with HTTP, it's not just about counters. You also get to see your keys. So here we're looking at the top 15 hottest keys on our site in terms of operations per second. We can get throughput for these. We can get durations for these. All this stuff is available. And it's pretty amazing. Like, your site's acting really weird. Your databases are getting beat up. Like, why is that? Well, it's pretty easy. Fire up your tool. Go look at your Memcache misses and see what are you missing on something? Did a developer check in some code and they named the key wrong and now you're looking for a key that doesn't even exist? So it's pretty exciting. The last example is Java. So does anybody here monitor Java applications? Excellent. So I've been monitoring Java applications for a long time, and I've been waiting for this for a long time. So we're going to use Tomcat as our example, but it could be any Java process. It doesn't actually matter, even whether it's in a container or not. So it used to be back in the day when I wanted to monitor my Java applications, I would run jstat -gc, and I would take all the output of that with a Perl script, and I would shove it all into RRD. And that worked out okay. Or I would use something like JMX-trans or something like that that could go around and poll all my instances. Well, polling still kind of sucks. Like, if I'm in a cloud environment and I got 100 servers popping up and 100 servers disappearing, how often do I reset my poller? Like, every minute, every 15 seconds, every 5 minutes? I don't know. Like, how do you decide that? But with sFlow and the sFlow agent, I drop in a jar, I restart, and 15 seconds later, all my data is visible in Ganglia. It's kind of crazy. So earlier this year, I was working with some interns, and we wanted to build, I don't know what I want to call it, not Splunk or something. I don't know. We wanted to build a logging system so that all our developers could go and look at their application logs and figure out what's going on. So we settled on Elasticsearch and Logstash, which is Jordan Sissel's project, and it's a JRuby implementation, or it's a JRuby project, and you should check it out if you haven't. So my interns came to me and they're like, well, we set it up, it's kind of working, but it kind of runs like garbage and we don't really know what to do. And I was like, well, we're not going to know unless we instrument it. So literally we stopped these processes, we threw on the agent, we restarted, boom, we started seeing all the graphs. We started seeing like how much heap was being used. Oh, okay, well, Elasticsearch, it looks like, wants to use tons of heap. So let's really bump that up. And Logstash actually didn't really have to use very much heap. But there was no way to know this. And, with applications like this, like, what are you going to do? Like, you're going to get on the IRC channel and be like, well, I have my specific application that does X. Can you guys tell me what to set it to? Like, they're not going to know. Like, you got to actually be able to figure this stuff out for yourself. And getting this kind of visibility, what I like to call drop-in visibility, is really awesome. So here's an example. So this is a graph over a week. And this was an application that was giving the guys and ops fits because it would run just fine for like 5 days. And then it's 3 o'clock in the morning and your pager goes off and you're like, what's wrong with this application? And you wake up, you're tired, you restart Tomcat, you go back to sleep, and everything works great for another 4 days or 5 days. And what's going on? Like, this is just getting really annoying. So we were rolling out sFlow at the time and we dropped it in, and all of a sudden we looked and we're like, whoa, the heap just keeps growing and growing and growing. It never stops. The objects are not being able to be reaped by the garbage collector. It's basically like an object leak. Like, we went to the developers, we're like, look at this. This doesn't make any sense. You shouldn't be doing this. 2 days later, they had a fix. The thing never alerts us again. And being able to see this kind of thing as an operator is crazy. Because in the past, if you wanted to instrument all your applications, you always have to go to the developer and say, can you drop in this instrumentation? Can you do this? Now, I don't have to do that anymore. If I want to instrument my JVM, I drop the thing in, I restart the service, and everything just starts showing up. There's no intervention required. So that was pretty cool. And it's not just the heap that we can look at. You know, there's JVM classes loaded, there's compilation times, there's all kinds of other metrics that are coming out of the JVM. And it's really, really fun to have. And it's also really, you know, if you want to make a roll-up graph or something like this in Ganglia, you can do that too, just like we said before. It's just a little bit of JSON. So the only thing that there isn't in here really is like the equivalent of a URI or like a Memcache key, and I don't know exactly how that would be represented in Java, or yeah, for Java. So the last thing I want to talk to you guys about is tcpdump, I guess. So has anyone here ever used tcpdump? All right, this is quite a network savvy crowd. Does anybody here know like Perl or Ruby or Python? All right, so you guys have all the tools that you need to be able to utilize sFlow tool. And what sFlow tool is, it's something that's very similar to tcpdump. It's basically taking your raw data from the network and it's translating it into something you can actually do something with. It actually makes it like human consumable. So the data that you see flying by here is the exact same data that's going into your Ganglia instance or your other sFlow collector. And you can take this and you can pipe this stuff into a Perl script or a Ruby script or whatever you want, and you can do whatever you want with it. So the nice things about it is it's open source. It's a command line tool. It understands tcpdump. I mean, if you actually have a bunch of tcpdumps that have sFlow data in there and you throw it through here, it'll actually spit out the sFlow data for you. It's pretty awesome. And it output in delimited text, which anybody can pretty much parse. So if you want to take the data and drop it into MongoDB, you can see an example of that on my GitHub account. If you want to write it and put something into a complex event processor like Esper, that's totally fine. You want to write an input plugin for Logstash, it's all up to you. You want to aggregate the data, send it to statsd, Graphite, no problem. This is kind of like your reference point for number one, understanding like what the sFlow structures are, and number two, being able to take like this data and do whatever you want with it. And so I think Peter and I would both like to encourage like everybody to take advantage of this kinds of things, you know, get the community involved and start instrumenting a lot more things so that we can get this common transport and methodology for getting the metrics into our systems. So we want to thank a bunch of people. I definitely wanted to give a special shout out to the Bay Area LSPE meetup group, which is where Peter and I met. They're actually having a meeting tonight. If you liked looking at cool graphs today, they're having a talk tonight on actionable metrics over at the Yahoo campus, so you might want to go check that out. And anybody have any questions for myself or Peter?
Question over here.
Sure.
No.
Question was, is there support for cryptographic signatures?
No, it's kind of left to the imagination of the network operator. So it's just UDP datagrams. If you want to drop it through an IPsec tunnel or something, it's up to you. But it's designed for LAN environments. Typically, you'd put it on a management VLAN or something. If you want to put it over the WAN, you use a VPN or something.
Any other questions? I have a, oh, go ahead.
So, is it pretty easy to, like different languages, to add application-specific metrics, like stuff you put in your code that you want to monitor and send it through sFlow, so like you do stats?
The question was, is it easy to instrument your own code in a manner similar to statsd? And the answer is yes. I was inspired by statsd, and we added the capability so you can send a JSON ASCII message down to host sFlow, and then it'll map it into the host sFlow application structure and send it out. sFlow is a little different. In the degenerate case, you can use it just like statsd, but the point of sFlow is really to model services, and so it allows you to attach a lot more attributes to each metric, some like the client IP address, the server IP address, response time, status codes, not just a simple metric. And it's trying to model everything as communicating nodes. And so you either have things that represent the state of the node, or you have things that represent messages between nodes, and then you can assign names to the services, names to the operations, and so on.
I have a quick question. So let's see, with Apache you mentioned it's mod sFlow that'll grab everything. Thank you for that, because parsing scoreboard is a pain in the ass. But presumably it's getting the data from the same place that the scoreboard is getting it from?
Well, that's one of the metrics it's exporting. It's exporting you the number of active and idle workers and so on, just by reading the scoreboard structure in C, because it's a module. But it's also, it's sampling HTTP transactions, and it's also maintaining all the HTTP counters.
So that leads me to the second question, which is on with the Memcache metrics. Are those pulled off the wire? Is that how are those
They're pulled out of the shared memory variables. I mean, it's C code in the protocol engine.
Oh, right. It's because it's a patch.
Yes.
Okay.
So that's the whole. If you embed instrumentation, it's wildly more efficient than trying to tail a log. And so you can't notice any performance impact by turning it on. It's designed to be used operationally, not on an ad hoc basis. So it's there, it's always on, you always get metrics.
Well, if anybody else has any more questions, these guys are going to have office hours today at 2:30. Big round of applause.
Thank you.